Yes, put the Google Maps away, the Google Earth. Street View has come to Bangladesh, yes. It's been available for a little bit.
Have you seen the Google cars around here?
The what?
Have you seen the cars?
No, I haven't seen any cars.
Yeah, I've never seen a car.
I saw one.
I saw it. Did you?
That's right.
Leave it up to the Koreans, they see everything. Probably took 20 pictures of it too. Love you guys. Okay. They should bring it up. They're not ready. All right. Here we go. So the other day we kind of started graphing trig functions, and I went through some things. We went through some basic stuff. Now I'm going to walk you through this. Like I said, I found this online. It's really good. Kind of a modified PowerPoint. All right. Yes. Come on, Jim. All right. So we went through. We talked about some things. We went through. We talked about what what the period is, and what it means to be a wave function, the physical waves, the crest and the trough, and those types of things. Now we're going to talk about this in terms of trig. Okay. Now, at the top of the wave is the what?
The crest.
The crest, or the maximum. At the bottom of the wave is the what? The minimum. Now, untransformed, that goes back to our unit circle with what is the maximum, or which one is on the y value. And this is where your unit circle comes in. Which one is on the y-axis? Sine. Okay? Which one is on the x-axis? Cosine. On your unit circle. Now, we're going to take those values that are on the unit circle and put them into a coordinate plane. The xy value on the coordinate plane is not going to be the sine cosine. It's going to be back in terms of our domain and range. Okay? So that's the slight difference between the unit circle and what we're doing now. Okay? But for both sine and cosine, what is the maximum value that you're going to have? 1. What's the minimum value? -1. Okay, so all of your range values are going to be between 1 and -1, inclusive. All right? Now, because it's a circle, because we can go positive, we can go negative clockwise or counterclockwise, then we can go beyond, and does our domain stop? Does it stop when we get all the way back around through our unit circle? Back here, we hit the underside of the positive x-axis at what? What is this value?
1.
Angle value. 360 degrees or
2 pi.
Or 2 pi. Okay? Now, once we go past this, what happens? We go beyond 2 pi. We don't go back to 0, we go beyond 2 pi. So when I go all the way around and then go back halfway around to the other side, I'm not at pi, but now I'm going to be where? 3 pi. Come around again, then I'm going to be at 4 pi, 5 pi, 6 pi, and it works negative as well. So our wave will just continue on. Okay? Now, there are some other key points that we're going to look at, not just the maximums and minimums, but we're going to look at where this thing crosses the x-axis, or x-intercepts. What do you know about where the graph of a function crosses the x-axis? 0 is the y. Okay, so when your 0 is the y. So when do our values, our sine and cosine values, come out to be 0? When they come out to be 0, that's where they cross the x-axis. Those are the points that we're really going to focus on. Now, if we look at a positive full period and a negative full period on a sine function, you notice that some characteristics. Well, at zero, I'm probably going to paste this back up here. At zero, okay, at zero, what is our sign value?
0.
0. Okay, so at 0, our sign is 0. So that corresponds right there. Now, as I go on, now, like I said the other day, we're going to focus on some main domain values, some consistent domain values. We are only going to concentrate on the quarter values. Okay, pi over 2, pi, 3 pi over 2, 2 pi, unless we have to transform those. Why? What happens at pi over 2? At pi over 2, what's our sign become?
0.
1. At pi, what happens to our sign? It's 0. At 3 pi over 2, what happens to our sign? Negative 1. And then back at 2 pi, sign is 0. Okay? So these points right there come from our unit circle. Those are our 5 key points. Well, if I go backwards, the same thing. If I go backwards, and backwards meaning clockwise, or in my negative angle measures. If I go negative pi over 2, well, negative pi over 2 is right down here. What's my sign value? What's my sign value at negative pi over 2? Or 3 pi over 2?
0.
At 3 pi over 2, it's negative 1. At negative pi over 2, it's negative 1. Okay, I'm down here. Now, negative pi, come back around to here. 0. Negative 3 pi over 2. 1. Negative 2 pi. 0. So I have this same wave on both sides. Okay, so in other words, if I could pick this up and move it and set it right down on top of it, it would be the same thing. Okay, it'll be the same thing. What can't you see? You're squinting. Okay, so this pi over 2, pi, then what do you think the next one's going to be? 3 pi over 2, and then 2 pi. Those are our 4 of our 5 key points. Where's the 5th one?
Origin.
Well, not the origin, but what? Domain values. 0. Now, what are these? What are these values corresponding to? The x values on the unit circle, all right, but in this case, it's actually our y values on the unit circle. But what are these? 0, pi over 2, pi, 3 pi over 2, 2 pi. What are those values? These are our x values. What is x here? What do they correspond to? Radian measures of the what? What gets measured in radians? Angle. Sine of an angle. So we're looking at the sine of 0, sine of pi over 2, sine of pi, sine of 3 pi over 2, sine of 2 pi. So we're looking at the sine of these angles. Okay? So our angle measure is on the x. The sine of the angle measured is on the y. So in other words, theta is on our x. Sine theta is on the y. All right? Same thing for the cosine. Theta is still on my x, but now instead of sine theta on my y, it's going to be cosine. I still use the same 5 key points for my theta. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, what's the only difference that you notice between these two graphs? Okay, the starting point. That's what we talked about the other day. What's the difference between sine and cosine? Remember the phrase that we said? Phase shift. Okay? Cosine is just a phase shift of sine. Because when we go through our unit circle, they all come out with the same output values. Okay, so the wave follows itself. It's kind of like two dolphins. Okay, the cosine in a way will follow the sine. Okay, so those are the way that the sine and the cosine look. And we'll get a little bit of practice doing this. All right, and again, we are going to concentrate more on the radian measures than degree measures. But if you really wanted the degree measures, what is pi over 2? 90. What's pi? 3 pi over 2. 2 pi. 360. And if we go on, we would just go multiples of 90 degrees. Same thing. Negative 90, negative 180, negative 270, negative 360, and so on and so on and so on. Okay? Now, general rule of thumb, unless otherwise stated, your graph that you're going to be looking at when you graph a trig function is going to be between negative 2 pi and positive 2 pi. Now, a lot of times they will break that down and they'll go from 0 to 2 pi. Okay? But for the most part, you will be looking at between negative 2 pi and 2 pi. Okay? Even on your calculator. We'll talk about how to adjust that window in your calculator so that it's accurate. All right? Well now, tangent. Tangent is the one that we kind of don't look at as frequently. Okay? But there's your tangent graph. What does the tangent graph kind of look like? Kind of looks like x cubed. Okay? Kind of looks like a cubic function. The difference between the two is that this is also tangent has a period. X cubed is just one graph. Okay, and this has values over each one. Because remember, how is tangent defined?
Sine divided by cosine.
Sine divided by cosine. Okay, so this is what the tangent looks like. We still have this. Why? What are these dotted lines? Asymptotes. Why are there asymptotes? Why can't it go past that? Because, remember, sine, theta, cosine, theta. Why is there an asymptote? Yeah, when is cosine equal to 0? Cosine is equal to 0 when? Is cosine of theta equal to 0 at 0? No, that's why we have a value. Is cosine of theta equal to 0 at pi over 2? Yes, at pi over 2, that's why we have an asymptote. Is cosine of theta equal to 0 at pi? No. But it is again at 3 pi over 2. So every pi over 2 multiple, okay, at every odd pi over 2 multiple, because 2 pi over 2 doesn't work.
He transformed.
Okay? At every k pi over 2 multiple, when k is odd, you're going to have a vertical asymptote. Because at every odd pi over 2 multiple, cosine of theta is 0, which makes this undefined. Okay? So be careful. Again, nothing really fantastic. This is just using all of our algebra rules, just putting the algebra rules in terms of trig. Good to go? Yes. This graph is only, this restriction is only for tangent graphs, yes. Because when we're just looking at the cosine graph, it's okay if we just look at the cosine graph to have an output of 0. Correct. Well, there's actually 6, but we're only looking at these 3. Because then we can look, because there's also a secant graph, a cosecant, and a cotangent. We're not going to look at those. Okay? You guys get into calculus in college, you'll look at the secant, cosecant, and cotangent. Then you'll also look at the all of the arc cosine, arc sine, arc tangent, arc cosecant, arc secant, and arc cotangent. You'll look at the graphs of all of those as well. So yes, there are 6 basic trig functions. We are only looking at the graph of 3 of those 6 though. Sine, cosine, and tangent. Now, how do we obtain the graph of the sine? How do we obtain the graph of the cosine? Oh, right on top. Figured that was going to happen. Yeah.
When we're trying to find sine and cosine with the equation, it's going to tell us like find the sine equation, right?
It'll tell you. It'll say find the equation of sine, and I don't like it, but it'll say sine x or sine y. I prefer. You'll see this all the way through here. It says sine x, sine. I don't like x because typically when you guys think of x, you think of x as a length, as a value. In typical rule of thumb, Greek symbols are angle measures. Lowercase letters are sine lengths. And I'm kind of old school in that, so you won't see me write sine x too much. You'll see me write sine theta, cosine theta, tangent theta, or alpha, or beta, or whatever. Okay? Now, there are 5 key points. Okay, 5 key points, and these are the points that you always need to focus on. Just like when we went back with our parent functions, when we graphed the functions earlier. You always had key points. Now your tangents are always going to have key points. Okay, well our x values, our input values, our theta values, we're going to start at 0, and then we're going to do multiply over 2. Okay? Well, now, if we're looking at sine of 0, what's sine of 0? Sine of 0, 0. Sine of pi over 2, 1. Sine of pi, 0. Sine of 3 pi over 2, -1. And 2 pi, 0. Now, when we look at 0, 0, what kind of point is this?
Origin.
Okay, it is the origin. Get away from the y-axis though. What happens when my y is 0? What do you call it? Which intercept? X-intercept. What is a value of 1?
What's the point?
Is it going to get any bigger than 1? No. So if this is the biggest value, what do we call that? Maximum. Then it comes back. What happens?
Y-intercept.
Not a y-intercept.
Oh, never mind.
X-intercept. Then it goes down to -1.
Minimum.
So that's going to be a minimum. Then it comes back and is what? X-intercept. Now, what do you notice in one period of sine? 3 x-intercepts. There are always going to be 3 x-intercepts in one period of sine. What else?
First one also 1. First one's also 1, just like that.
Yes, in this case it is.
Yeah.
What else do you notice? 1 maximum, 1 minimum. In one cycle of sine, you will have 3 x-intercepts, 1 maximum and 1 minimum. What else do you notice? It is a wig. Now, look very basic. Do you see any other patterns anywhere? Look a little bit deeper.
X-intercept. 0, 1, 0, 0, 0.
Okay, 0, 1, 0, negative 1, 0, yeah. Okay, it's repeating. They're alternating between 0 and positive negative 1. Where? What do you know about this value in relation to these two?
That's half. That's in between.
Where in between?
Like half of a period is that.
Well, this is happening in period.
No, it's not a full period.
Period is going to go through the whole wave cycle.
Okay,
So what is
yeah.
this?
That's 1/4 of a period.
1/4 of a period, but where is it between these two? Half.
Half, yeah.
Exactly half. You are going to have a maximum between two intercepts. And where does that maximum occur between the two intercepts? At exactly halfway. What about this minimum? Where does that minimum occur? Where between?
Between the x and
Where between?
half.
Exactly halfway. That's always going to be true. Okay? That may not seem like it's very important right now, but when you graph and I compress, I give you a horizontal dilation by compressing this wave, and you have to figure out where the x-intercepts are or the where the maximums are. And if I know where the maximums and minimums are, how can I find the x-intercepts? Exactly halfway. If you know where the x-intercepts are, where are the maximums and minimums going to be? Exactly halfway. So you're finding little cheats to get either the maximums and minimums or the intercepts. Okay? So yeah, it doesn't look like on this it's that great of a big deal. But when I compress my wave or I stretch it out, then it becomes a little more useful. Especially when I compress it and I stretch it vertically. Okay? So keep those things in mind because we are going to start to do all of that. We're not just going to compress it, we're going to compress it, stretch it vertically, and then we're going to move it horizontally and move it vertically. So we're going to be doing all four of those in the same thing. All right. Well, if that's the case, for the sine, is it going to be any different for the cosine? No. The only difference
The starting point.
is the starting, where sine started off with a what? Sine started off with
0.
Sine
Zero.
started off with
Yeah.
sine started off with what do we call that?
origin.
What did you call that?
X and
Minimum.
The x-intercept.
Not
Okay. Cosine's going to start off with a, thank you, a maximum. In this case, it is the y-intercept, but it's going to start off with a maximum. Then it's going to go to a what?
X and
X-intercept. Then it's going to go to a what?
Minimum.
A minimum. Then x-intercept. And then a maximum. And again, it may not seem like that it's very important right now, but trust me, when you're graphing these things, especially without your calculator on paper one, because you're not going to have that to fall back on, and yes, you will have to graph these 100% by hand. Okay?
PQR.
So you are going to need to make sure that yours goes max, x-intercept minimum, x-intercept maximum, all the time. Excuse me. Okay? And yes, they follow the same input key points. 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay? So it follows the same angle value inputs. We just get different outputs. Yes? What do you mean? Oh, all of our values are always going to come from this. Now, the reason that we use this, because the unit circle, because we spent so much time, because I made you kind of memorize that, these key points should come very easy. Now, again, I don't have to do much with these. This pi over 6 is on this graph, but I don't have to use that as one of my key points because it's not as very easy to graph square root of 3 over 2. Oh, it will be.
Or the minimum one would be -2.
It can be. When can the minimum be -2 and the maximum be 2? When I change my amplitude. Okay, when that leading coefficient is 2. Okay? So if I change this to y is equal to 2 cosine theta, then instead of 1, -1, everything will be the same, except my maximum then is going to be what?
2.
2, and my minimum is going to be
Negative.
-2. Are the placements of my x-intercepts going to be different?
No.
No. Are the placements of where the maximums and minimums going to be different?
Yeah.
No, only the maximum and minimum values, not their horizontal placement, because there is no horizontal change here. Okay? Now, I can make it 12, and in that case, instead of 1, -1, it's going to be 12 and -12, and so on and so on. But there would still, on the horizontal, they would still be all in the same place.
On the horizontal or
That's
vertical?
vertical.
On the vertical as we move horizontal.
All right.
So amplitude is basically vertical dilation.
I'm sorry, what?
Basically vertical dilation.
Amplitude is the vertical dilation, yes.
So in the transformer, you would still have the vertical amplitude, right? That's how-
Yeah. Because I can stretch out my tangent really, make it really skinny, or I can make it really pronounced.
So it's
So what's
a
in the-
generic equation. for
That's
transformer
the
one
first
is
grid.
tangent of E times X minus
It would be all of this.
It's easily sine.
I remember good times. You didn't have to study.
It's still, well, it won't have all the same components because tangent's not a wave function.
You got 40.
But we can have a vertical dilation and a horizontal
That was my
dilation. So
first
instead of
class.
4 pieces, it's only one.
I got a B plus.
If it's attached to the X, remember, anytime it's attached to the X. So yes, okay, and that, you would have those 4, if you're gonna put them in the 4 different places.
I always like this.
All right, now, we talked a little bit about amplitude the other day, but here's a little bit of a visual about amplitude. Okay, now, this wave, sine and cosine, has an equilibrium line that's gonna split, and where's the equilibrium line going to be? Well, if it's untransformed, it's gonna be the x-axis. But if it's transformed, I don't care where it is, I know that my line of equilibrium is always going to be
Middle.
exactly in the middle between my maximums and my minimums.
That's-
So even if it's moved up or down, my line of equilibrium is always going to be exactly halfway between my maximums and minimums.
Maximum.
In other words, if I move it up and down, I can't have a wave function and this be my equilibrium, because the distance between my equilibrium and this maximum is not the same as my equilibrium to my minimum.
Maximum minus.
Okay? It's always going to be exactly the same. Okay?
No, max the minus and then divided by 3.
Well, you find your maximum. If you know your maximum and you know your minimum. Say your
Whatever
maximum
comes first,
is,
right?
I don't know, say your
Yeah, it does
maximum is
depend.
8. Give me a number for your minimum.
2.
2. So if I've got a maximum of 8 and a minimum of 2, how am I going to find halfway between? Well, figure. So if your hypothesis is 8 plus 2 divided by 2, 8 plus 2 divided by 2 gives me 5. Is 5, how far is it between 8 and 5? 3. How far is it between 5 and 2? 3. So if you know your maximum, you know your minimum, add them up, divide by 2. What do I do when I add two things divided by 2? What do you find?
Just that average.
Average. Your equilibrium is the average of the maximum and the minimum. Okay? And that's true once you get into physics and you're looking at those sine and cosine waves as well. That's true there too. I don't know if you're in that point or not. Okay.
Wait, what does Q stand for? There's like PQR or ABC.
It depends on where the placement of P's and Q's and R's are. Okay, this, I know what you're talking about.
Yeah.
Okay, now, this is written slightly different than the one I showed you the other day. The one I showed you the other day has this piece back here, and this is written with one less piece inside. Okay? Well, just like we said just a minute ago, my amplitude is the same as my what that we dealt with parent functions. You're right there. You're right here. What is this one? What did we call this?
Stretch.
Which stretch?
Vertical stretch.
Vertical stretch, but we also call that vertical dilation. So, same exact rules. The same exact rules as when we had y is equal to ax, let's see, let me write it this way, a times x minus h squared plus k. Where is my vertical dilation? A. How do you know A was my vertical dilation for that?
It's a coefficient.
Because it's multiplied by my function. My function is a square function or the quadratic. Whatever I multiply by my function, that is my vertical dilation. Well, my function here is my sine function. I multiply it by my sine function, that's my vertical dilation. That's my amplitude. My cosine function, here's my cosine function. I'm multiplied by that function, that is my vertical dilation. Same exact rules, just a different function. Yes? We're getting there. Okay? We're getting there. That's where, what's inside here is the hardest part about the wave function because it gets slightly confusing. But if you follow it in terms of what we did with functions, you're going to be golden. Okay? So whatever you're multiplying by your function, that's your amplitude. Does tangent have an amplitude? Does tangent have an amplitude? No, why? Tangent's not a wave function. Sine and cosine are the only wave functions. Tangent's not a wave function, therefore tangent doesn't have an amplitude. Okay, another physics question. Okay, that a lot of physics teachers like to throw in there. What is the amplitude of the tangent function? It's a trick question. There is no amplitude of a tangent function. Okay? All right. Now, this is what's tricky. Okay? This is what's tricky. Keep in mind, what did we say at the beginning? How long does it take for a sine or cosine to go through the entire unit circle? 2 pi. So our period is going to be whatever is multiplied by my x, my b in this position. 2 pi divided by that b. Okay? My period is 2 pi divided by that b. All right? Now, if we manipulate this in terms of b, if I manipulate this and solve for b, b is going to be equal to what?
B is period. Probably no.
2 pi divided by the period. Okay? So b is equal to 2 pi divided by the period, and that's the tricky piece. Okay?
Why don't we leave it like that?
Okay.
Leave it like
Now, B is the constant multiplier for the period. Keep in mind your period. It's your period change. Okay? If B is 1, is there a period change? No, because the period of my sine and cosine is 2 pi.
Yeah.
Okay? But if I have a change in my period, it's going to adjust whether I end at 2 pi, whether I end at pi, whether I end at 3 pi, whether I end at 4 pi. Or maybe I end at 2 pi over 3. Okay?
So it's period like this.
Period is how long it takes to go through one complete wave. Okay? All right. This one I'm going to hang on to. We're not going to. It's the most difficult part. Okay? Not hard, but it's the most difficult part. Now, just like this guy, where's my vertical translation for this guy? Okay. Is it K? Sorry, it might be the glare. So it's my K. Well, how do you know it's your vertical translation? What did we say was the rule for vertical translation?
The shift.
It's after my function. Okay, it's added or subtracted after my function. Does it follow the sign or go opposite my sign? My vertical translations follow my sign. So if it's plus K, which way is my graph going? Up. If it's minus K, which way is my graph going? Down. Okay? Same thing for this. Same thing for your sine and your cosine. If that thing that is getting added to my sine and my cosine after the function is positive, my whole wave goes up. Okay, and remember, the other day we wrote it like this. Okay, so if it's plus D, wave goes up. Minus D, wave goes down. Doesn't change the amplitude, doesn't change the period, doesn't change where my starting points are. Takes the entire function and moves it up or down. D does. Just like this one did. It moved the entire, yeah, I'm dancing.
Yeah.
Okay? You go, hookah, hookah. All right, so it moves it up and down. All right, moves it up and down. Same thing over here.
That is so small.
What's the matter?
You have to go to the dance class tonight.
I am I'm an amazing dancer.
Oh, you are.
Of course I
Are you
am.
sure?
Just follow the math, right?
Is it just math dancing?
Yeah, just math dancing, yes. Now, horizontal. Back to this guy. Which one changed my horizontal translation? H. How do you know it was H? It's attached to my domain values. Anything attached to my domain values affects my horizontal. What's the rule for horizontal shift? Opposite the sign. So if it's minus H,
Goes to the left.
Right.
it goes to the right. If it's plus H, goes to the left. Same thing with our sine, cosine, and tangent. If it is an adding or subtracting within the theta value, within the angle value, it's going to move it left or right. Okay? In terms of our sine and cosine, okay, our phase shift. That's going to tell us where we're at. Now, the whole phase shift is this C divided by B. All right? Now, for IB, we're not going to be, they don't ask, I can't remember too many questions where they ask for a phase shift. So don't get hung up on how to find the phase shift. Okay? So if you're looking for a phase shift, because that's more of a physics question than it is an IB math question. Your physics question will ask about a phase shift.
So it's not just minus C, like it's minus C.
That is going to tell us where it's going to, like how far it's going to slide, but how far it's going to slide is not necessarily what's considered the phase shift. Okay? And as far as we're concerned, that tells us how much we're going to move left or right. Is that plus or minus C? That's all we need to know about that. Now, we talked about these the other day. Asymptotes. What's an asymptote?
Yeah, any that
A gap either in the, good job, cheater. Okay? Very simply put, asymptotes are gaps in the domain or gaps in the range, for the most part. Okay, there is one situation where the asymptote is not a gap, but no. As far as our trig functions, we're looking at, let me say it this way. Your vertical asymptotes are always a gap in the domain. Your horizontal asymptotes are just either where your range values are going to get either max out or converge to or minimum out. The vertical asymptotes are always a gap in the domain. Okay, I'll just say it that way.
It's cool for both.
I hope you guys are getting that because I'm getting this whole conversation. Now, asymptotes for tangent, cotangent. I know we're not going to deal too much with cotangent, but where are your asymptotes going to be for your tangent and cotangent? Well, tangent, where's tangent? Well, what is it? Define it.
It's a skip school for them.
Where's, don't you dare say sin and cause. I'll slap you out of that shit. Thank you. So, cotangent is what?
Cosine and tangent.
Which way?
Tangent divided by cosine.
Not quite. Not quite. I will tell you it's cosine.
Inverse.
Over
Cosecant.
sine.
I was
Okay?
Why the code?
Because somebody likes to call it cotangent. Okay? What do you want to call it?
Why is nose called nose?
Why is left left? Why is it a right angle?
Why is there minus?
Why do you have a pair of shoes and a pair of pants?
You're not woman.
Why do you drive on a parkway and park in a driveway?
I don't know. Those are all like.
Why do you
small
sit in the
kids'
stands? Why do they call it jumbo shrimp?
questions. Do they?
Why do you drive on a parkway and park on a driveway?
Oh my god.
Why is there a minus?
Now, so back to this. Where are the asymptotes? Where are the asymptotes for your tangent? Why? Where is that? Why? Where do we find our asymptotes? How can I find the asymptotes? For tangent. Okay? Shh, ladies and gentlemen. So, cosine theta equals 0. That's your tangent. Or excuse me, that's your asymptote. So where are the asymptotes for cotangent? Sine theta equals 0. Well, way back we said,
Sister.
where's cosine theta equals 0? What value? Where's cosine equal to 0? Pi over 2, 3 pi over 2, 5 pi over 2.
You dance guys.
Okay? Yes, doing the robot. Okay. So we're at odd multiple pi over 2s for the asymptotes for tangent. What about cotangent? Where are the asymptotes for cotangent? Where is sine equal to 0? Do your dance moves. Not here.
Sine is
Sine is going to be perpendicular to this. See? Not only am I teaching you how to do some math, I'm teaching you how to do some dance moves.
I bet I can't even do that.
Probably can.
Feels too late.
And then when it breaks, it's
Can you twist one and like this right?
no, but I can do that.
Can you?
What is that?
Whoa, how do you do that?
You can do what?
Whoa!
You can do that.
Do what? This?
It's still.
What?
So can I?
That.
Like me too.
Like this?
I can almost do it. Oh yeah. I can almost do it.
I love showing that because now, if I could take a still photo, everybody's like,
No, you can put this
Like this. No, like this. This thing.
I'm so close.
Like a dinosaur.
Tell me how to perfect it. I'm so close. How do you do that?
I'm good than you.
You practice this. You're boy.
Yeah, I can do that. I can do it on my left foot.
I'm double jointed. Like this.
that's my pinky up a long time ago.
How? How?
Playing
No,
football.
is this like this?
That's where I messed up the ligaments and tendons or something.
This is my. Look, look
Okay.
at this.
I'm like, you should show what
You know, that's crazy.
you like.
Look at it. No? It's my elbow.
Can you
I
do
don't
that?
have my hands too. Do it.
He can't.
Yeah.
Oh my God, how do you do that?
Do what? Walk? I can't do
You
that.
need to learn how to do this. This is not peace. This is live long and prosper.
That's Spock.
Spock. He just passed away last week, so.
Really? What?
Yeah, the original one.
Leonard Nimoy died.
That does not mean living. I mean,
Live long and prosper.
really? But he can't prosper. He's dead.
Wow. Did you really just say that?
I'm gonna ignore that. Okay, here we go. So, tangent is odd multiples of pi over 2. Cotangent is even multiples of pi over 2, or multiples of pi, because you get pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. Okay, so pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2. Okay, odd, even.
Dude, my house is orange.
Here's what, wait, can you do that?
Yeah.
KFC goes.
If I do it to this one.
She's like this. She's like this. I can do it.
You like this.
Do like this.
Oh.
Jeremiah.
Okay.
You should sing up here.
All right.
You like sing up here? You should sing up.
Okay. Here we go. I can't believe you guys never tried it.
Skip it.
All right. So we've done sine, we've done cosine, tangent. To get a graph of tangent. To get a graph of tangent. The first thing that you need to do is find this. Find your asymptotes. Okay? Put in your asymptotes. Put in your asymptotes throughout the domain that you are asked to graph on. Once you find your asymptotes, you know that your graph is going to be in there. Then, so you find where cosine is equal to 0. Then the next easiest thing is to find where sine is equal to 0 in that. Okay? Why do I look for when sine is equal to 0? Where's that going to be? If I look at my tangent graph, actually, that's gonna be there. Why do I look for when my sine is equal to 0? What's that gonna give me? My x-intercept. Okay? So I find my asymptotes when cosine is equal to 0, and I find my x-intercepts when sine is equal to 0. Those are the two easiest things to find with your tangent. Then once you find where that x-intercept is, then you can wisely choose, just like we've done before, you can wisely choose 2 or 3 other points that are close to that x-intercept that you can find the value of. And then you connect the dots and follow in your pattern. Okay? So tangent is not that bad. I'm not going to concentrate on tangent right yet. I really want to get into sine and cosine. All right. Looking at this. This is an important chart that you might want to copy. Okay? So what's going across the top is period, symmetry, domain, and range. Maybe I'll zoom in on this a little bit. There's no values. You are a genius. Can't get anything past you. You are too quick. Okay, so let's fill in these missing values.
That was what I'm saying. There's no.
Okay, so for sine theta, sine x. Oh, I'm sorry, I'll wait. I'll let you catch up.
Let me do this.
Or better yet, see if you can fill it in.
Ah.
Oh, that's a challenge. Sure.
This is the first thing with the most points.
Symmetry.
Sure.
Yeah, chocolate.
So,
So all the ones to New York.
I'm just amazing at things.
Ow!
I know.
That's my life.
I've got 3 x-axis.
How?
What? I know, right? I can't either. You stole the chocolate that shit.
You still do.
Why did you go? Because he gave me one. Why didn't you get one?
So he gave you, he gave you guys after.
Oh my God.
Oh, he's busted now.
you guys got chocolate?
If I know you get that upset about not getting chocolate, maybe I'll just have a bowl of chocolate in here.
Okay.
Maybe I'll get you to do some work.
It would be a good incentive.
No, it would not, because I know I wouldn't receive any. It's only for visual purposes.
So he gave you the present.
Okay, who can come up here and fill in this chart?
When I say I'm a visual
What do you want, 2/3 of the chocolate?
No, don't give him any more chocolate.
Can you fill it in then?
I didn't look at this.
I know how to do it.
So too busy worried about
So
chocolate.
easy, I don't want to.
Yeah, man, I can do it.
Oh, I can fill out
You fill out the one for sine?
for all of it.
Yeah.
Symmetry.
Okay, here's the deal. I cheated for you. You
Is it
split the
untransformed?
chocolate.
Yes, this is untransformed. This is just the graph of sine of theta. This is just a graph of cosine of theta. This is a graph of tangent of theta.
I don't know what it's called.
Just go periods.
No takers, no filling it in?
I know the period for all of them.
I know period.
You know the period?
That's actually how I remember.
Isn't symmetry the line that's like equal for both sides?
I don't know.
Minus
So, this guy says it's 2 pi,
It's 2 pi.
2 pi, pi. 2 pi, pi.
Isn't it?
Hey, by the way,
3.5 symmetry for sine x.
what's in 2 days?
Pi.
Pi day.
I just guessed.
Can we have a party?
Sure.
Pi day.
Are we coming to your house? Because that's on Saturday.
Oh, man.
Wait, is it like Pi day or
Guys,
math?
can we come back?
Is it math day or like? Pie like
What?
what type of pie day is it? Is it like the food or is
International Pie Day.
it like
Pie Day.
is it
Because there's 3
but do you eat pie on that day? Yeah? You do?
Yeah.
Can you make us pie?
No.
Why?
I gotta make my own. No, typically I would do a full-on lesson with, actually you guys would fit real nice because you just finished up your length and sectors and area that, like a whole lesson for pizza and anything circular.
Just to get us hungry and like not feel
To enjoy pie, I mean, who doesn't like pie?
If there's no coconut.
But if you
Okay, let's skip symmetry because there's some questions about symmetry.
Isn't it the middle for this?
Who, what? What about it?
Never mind.
Symmetry, isn't symmetry the x-axis? for
Yeah,
symmetry?
x-axis, and then tangent would be, hey, no, you can't do it. K, pi over 2.
For both of them, it's x-axis, sine and cosine. Yeah, I'm sure.
I don't know.
Okay, well, like I said, let's hold that symmetry thought. What about the domain?
Domain is from -1.
That's the range.
Yeah.
Domain would be from negative by.
No, it will be all real.
Wait, is it confused? I thought it'd be invisible.
always
Domain is my x values, so what x values can I put in for my sine?
all real
Yeah.
numbers.
All real, okay? So,
No,
Numerous.
Yeah.
todos no eres.
okay, theta is an element of the real numbers, okay? Now, typically if we are gonna restrict this, we're going to go from -2 pi to 2 pi. Okay, but that will be a restriction because there are no gaps. We don't have anything that we cannot put in there. How about for cosine? All real numbers again. How about for
When did you skip?
tangent?
You said the international skip there and that.
Jeremiah,
It is.
Yeah, it's on my calendar.
Okay.
I have one per semester per quarter.
Theta
Which meeting at all?
cannot equal a
Two, five.
k is n.
You're crazy
I'm really crazy.
too. I'm not crazy, lazy.
Okay. Theta can equal k pi over 2 when k is an odd integer. Positive only,
Negative 2.
negative as well. So it's a positive odd integer or a negative odd integer. She burped in your face. It's so gross. Okay, what is the range?
1 to -1.
1 to -1? What about for cosine?
Same.
Same.
Smart bitch.
What about for tangent? All real numbers? Why is that?
It's in.
It does all real numbers because there's no.
Yeah, there's no hard one.
So it continues going up and it continues going down?
Yeah.
Now, part of your homework, and some of you I think already have it, is to figure out what this is. And I don't need you to yell it out right now, okay?
Yell it out.
So figure out what this symmetry is that goes in there. Okay? Now,
Well,
Yeah.
yeah. What about Trig? Really? It's not.
Oh, God, I'm gonna say.
What?
Yeah.
That's it, hardest.
Now, the other part of your homework is this. So you've got 12 problems. You gotta graph these 12 problems.
It's a date.
March 12th.